All right, guys, Northern Oklahoma College, College Algebra Math 1513, Chapter 2, Section 4. This is part 2, I'm still trying to write the quadratic function in standard form by completing the square. Part 1 was just kind of showing you what quadratic functions look like on a graph and what everything does to a function. That negative flips it upside down, and sometimes it shifts left and shifts right and shifts up and shifts down. All right, we have 3 things I want you to do here. Well, 4, I guess. I want you to complete the square to change the quadratic function into standard form. Then I want you to find the vertex, I want you to find the axis of symmetry, and I want you to sketch the graph. So we got a lot to do here. All right, here's my function, x squared plus 6x plus 1. Now I want to complete the square so that I can write this in standard form. All right, before I complete the square, I want to show you guys one more thing. I want to show you the property of adding 0. If I add 0 to this equation, I haven't done a darn thing. I haven't changed anything. Adding 0 doesn't do anything. Well, think about what's the same thing as adding 0, all right? What if I add 6, but then right away I take 6 away? Well, isn't plus 6 minus 6, doesn't that turn into 0? Isn't that the same thing as adding 0? Okay, it is. Those are called additive inverses. They undo each other. Adding 6 and minusing 6 turns into a 0. So really, I'm just adding 0. And adding 0, remember, adding 0 doesn't change a thing. So what if I wanted to, let's just say, for instance, I wanted to minus 12. Well, as long as I add 12 somewhere along the line to cancel it out, these guys cancel each other out. They just turn into a big adding 0, which doesn't change a thing. All right, that's the trick we're getting ready to use to complete the square. All right, the first thing I'm going to do is I'm going to move my plus 1 over a little bit. I'm going to move it out of the way because I'm getting ready to put in the perfect number right here that's going to turn it into a perfect square, into something times itself. See, what we're headed for is this. Let me show you. Okay, what I want to get down to is something squared. All right, that's why we're completing the square. We want to rewrite it as a quantity squared. Now, how do I complete the square? You guys remember the trick. All right, the trick is take half the number by the x, that's 6, and then square that. That's 9. We're going to use both of those numbers. This 9 is what I want right now. The 9 is my magic number that I'm going to add right there. That completes my square. I'll show you in a minute how that works. But before I go anywhere, before I leave this line, I want to go over here on the end and I want to subtract 9 right away because I don't want to change anything. I don't want to change the function. I just want to rearrange it so that I can write it in standard form. Now this is one of the tricks that we use. To complete the square, I have to add 9. But to keep everything the way it was, I have to subtract 9 out there on the end. So basically, I'm adding 0 to it. I haven't changed a thing. All right, what do we have now? What I have now is an expression that factors into x plus 3 times another x plus 3. This right here, since I added 9, since I added that perfect number, it factors into x plus 3 times another x plus 3. Now, a little trick to remember in that is that 3 that we got there on the first part of our trick, taking half the number by the x. Half the number by the x gives us 3. That 3 is going to be that little number right there, if you can remember that little trick. All right, out here on the end, I have plus 1 minus 9. Put those together, that gives me a minus 8. X plus 3 times another x plus 3 can be written as x plus 3 squared, and I still have a minus 8 on the end. Okay, what do I need this to look like? I need it to look like it's in standard form, and it's almost there. Here's standard form. A times x minus h squared plus k. And we remember all those pieces there. The h and k are the coordinates of our vertex, our turning point. All right? And the a tells us if it's opening up or opening down. If the a is positive, it opens up. If it's negative, it opens down. So I'm going to take this right here, and I'm going to write it right beneath standard form, and I want to make it look like standard form. So I have f of x equals A is the number in front of my parentheses. What number do I have in front of my parentheses? Well, there's a 1 there. We don't write it, but it's there. Let's go ahead and put it. 1, open parentheses. Now, I want this to say x minus something. What do I have? I have an x plus 3. But plus can be rewritten as minus a negative. So that's what I'm going to do. I'm going to change the plus to x minus negative 3 because that fits my standard form better. And then on the end, I need a plus k. A plus k. What do I have? I have a minus 8. How can I write that as plus something? All I have to do is write plus negative 8 because plus and negative 8 means the same thing as minus 8. So now I have my equation written in standard form and I can answer my questions. Okay, first thing we're going to answer is the vertex. What is my vertex? My vertex is my h and my k, which is my negative 3 and my negative 8. So my vertex is negative 3, negative 8. What's my axis of symmetry, that imaginary line that cuts through the middle of my parabola? That's x equals h. What was my h again? My h was negative 3. Alright, here's what we had so far. We had the original function, x plus 3 squared minus 8, which we changed to x minus negative 3 squared plus negative 8. I've got negative 3, negative 8 in red because that turns into our vertex, negative 3, negative 8, and our axis of symmetry x equals negative 3. Now, we need to graph it. And when you graph it, you want to make a table, and you want, of course, you want to include the vertex, the turning point. It's going to be a low point, remember, because it opens upward. And you also want to include a couple points to the left. Okay, negative 4 and negative 5 are to the left of negative 3 on the number line, and a couple points to the right. So I picked those numbers there, negative 4 and negative 5 to the left, negative 2, negative 1 to the right. And let's fill in our table. All right, hopefully you paused the video and filled in that table by yourself. These are the values I get, so that's what we're going to graph. All right, I'm going to start with my vertex. So negative 3, negative 8 is 3 to the left and 8 down. 1, 2, 3, 4, 5, 6, 7, 8. There's my vertex. And then negative 4, negative 7 is 4 to the left and 7 down. Right there. Negative 5, negative 4 is 5 to the left and 4 down. Right there. And if we did our calculations right, we should see those two same points on the other side. Negative 2, negative 7, those two same y's. Negative 2, negative 7 is 2 to the left and 7 down. It's right here. And negative 1, negative 4 is 1 to the left and 4 down right there. See how those y's match up? If you did your math right, they should be symmetrical. And there's our sketch, okay? It's not exact, but that's a good sketch. We got our vertex. We got a couple points on the left and a couple points on the right. All right, guys, same instructions. Complete the square, find the vertex, find the axis of the symmetry, and make a table and plot a sketch, or make a sketch of the graph. All right, here's your function. Try and pause the video once in a while and see if you can beat me to the punch and figure out what's going to happen next. All right, first thing I'm going to do is move my plus 3 out of the way for a second because I got to put the perfect number there. Now, how do I find the perfect number? I take half of the number by the x, which is negative 5, and I take my answer and square it. Gives me positive 25. So that's the magic number I'm going to add here. Now remember, I have to minus that same number out there on the end to make everything 0, okay? By adding 25 and subtracting 25, I've really done nothing. All I did was add 0. They cancel each other out. All right, what's next? F of x, by adding that 25, I've broken this into a perfect square. It's going to be x minus 5 times another x minus 5. And remember where I found that negative 5? Right over here. If you can remember that, that's a handy little trick. And then plus 3 minus 25 is going to be minus 22. All right, a shorter way of writing this is x minus 5 squared minus 22. Now we're real close to having it in standard form. In fact, once you get better, you'll be able to read standard form right now. Standard form, remember, is a times x minus h squared plus k. Once we get it looking like that, we have everything we need. So f of x equals, what's my A? My A is 1, all right? What does that mean? Remember, it's a positive number, and the A tells us if it opens up or down. So now we know that since we have a positive A, our parabola opens up. Now I want x minus a number. So x minus 5. That means 5 is going to be my h. And then plus a number out here on the end. Well, I want plus a number. What do I have? I have minus 22, so I'm going to rewrite it as plus negative 22. That means negative 22 is going to be my k. So my h is 5 and my k is going to be negative 22. The 1 tells me that my parabola opens up. All right, let's answer our questions now. Our vertex is hk. All right, and we just found hk by putting the equation in standard form. So 5, negative 22. Our axis of symmetry, I'm going to abbreviate, is x equals h. And we just found out that h is 5. So x equals 5. Okay, next is come in the table. See if you guys can pause the video and figure out what's coming next. My vertex is definitely going to be one of my points in my table. So 5, negative 22 is definitely going to be in my table. And remember, the instructions say pick a couple points to the left. Well, on the number line to the left of 5 is 4 and 3. And a couple points to the right. So a couple numbers to the right of 5 would be 6 and 7. And now I'm going to do all the calculations. Why don't you guys pause the video and do the calculations for the table. Alright, so hopefully you did all the calculations and got these 5 dots. Remember, we already knew it was going to open upward because our A is positive, that number in front of the parentheses. Alright guys, last one, same instructions. Negative x squared is minus 2x plus 5. This negative x squared is a problem because negative x squareds are hard to factor. So we're going to do a couple things here on the next line. First thing I'm going to do is I'm going to scoot the plus 5 over like I always do because I got to leave room for completing the square. The next thing I'm going to do is I'm going to look at just this section here, and I would like that x squared to be positive so that I can complete the square. So what I'm going to do is I'm going to pull out a negative 1. I'm going to factor a negative 1. So if I divide those by negative 1, if I factor out a negative 1, I'm left with x squared. That's positive. I like that. My negative 2x becomes positive 2x. And I leave a little room there for completing the square. See if you can guess what goes in that space. Alright, you guys remember the secret over here. Take half the number by the x, that's 1, and square that 1, you still get 1. So I'm going to add 1 here. But we got to put our thinking caps on, see, because our instinct tells us to minus 1 out here on the end to counteract that. But we got to put our thinking caps on here. What did we really do? Right here when I added 1, I have to remember that I have to multiply that by negative 1. That negative 1 that I divided out, it's still there, and it still has an effect on everything in the parentheses. So when I say I added 1 inside the parentheses, what I really did, after you multiply it by that negative 1 out there, is I minused 1, because a negative 1 times a positive 1 is negative 1. I actually subtracted 1. Alright, I actually subtracted 1. It looked like I added 1, but I forgot that I divided that negative 1 out. That negative 1 still has an effect. Negative 1 times 1 is minus 1. So I actually subtracted 1. How do I counteract subtracting 1? I have to add 1 out here on the end. Alright, what do we got now? Hopefully you guys are working ahead and pausing the video. Negative 1. I'm going to take a shortcut here because I'm running out of time. X plus 1 squared plus 6. What does that tell us? Well, the first thing it tells us that negative 1, that's our A. Since it's negative, we know our parabola is opening downward. That means our vertex is going to be a maximum, a high point. Next, I know I want to make it look like standard form, so I needed to say x minus something, and then out there on the end I needed to say plus something, because that'll be our h and k. And so we have to write this as x minus negative 1, because we had x plus 1. And then on the end we have plus 6, so that's our k. So negative 1's our h and k is our 6. Alright, here's our information, vertex, axis of symmetry, and there's your table with your vertex in the middle, a couple points on the left, a couple on the right. Finally, here's our graph, and I noticed that I forgot to put in the axis of symmetry, so you guys go back and do that.